Okay, so this should be intuitive, but here are some comparison theorems. If your function is non-negative, if it's always positive over some domain, then the area between that graph and the x-axis will also be positive. Like we've said that from the beginning, anything above the axis we call positive area. This may not be as obvious, but if you think about it, if f is always bigger than g, then the area under f has to be bigger than the area under g because f is higher. And this last one, again, probably won't be intuitive at all. If f is bounded between two whole numbers, or sorry, two real numbers, then the integral of f, the area under f, has to be between not just those numbers, but those numbers times the length of the integral, your interval of integration. So let's just write something with that one. Here's f of x. Here's a and b. What this is saying is this function, he lives below capital M. He never gets bigger than 100 or whatever this number is. What this chunk is saying is this area here must be less than, let me get a colored pencil here, must be less than the area of this big rectangle. Well, what's the area of the big rectangle? The height is m, the length of this rectangle is b minus a. That's where this b minus a comes from. So the area under f is less than the blue area. Similarly, if I've got little m here, maybe he looks like this, that function's always bigger than little m. The area under f has to be bigger than the area of this rectangle. And this rectangle has area length, b minus a, that's this length, times his height, which is little m. So that's where these b minus a's come